Hi all, welcome to lesson 3. In this lesson we will start with conditional statements, then we will see logical operators. We will also see what are flowcharts and how these are helpful in writing programs. So let's start with conditional statements. Till now we have written very simple programs which are not very useful in real life. All the programs that we created had few set of statements, all of which execute sequentially one after another and completes the execution. So no matter how many times we execute our program, processor will execute each and every statement and in the same order. Now if we see some real life program, this is not the case every time. As we discussed, that program is nothing but set of activities, and most of the time we perform or skip some activities based upon certain conditions. For example, I want to go for a movie and I have planned few activities for that. Say, first of all I will book tickets, then take my bike to go to the movie hall, and finally after watching movie return back. Now suppose it is rainy season and thus I have to change my plan as per this condition. So if it is raining, then I would take my car, else I would go by bike. So here, depending upon certain condition, we are performing and skipping some activities, and this is what we call as decision making. To achieve this, in most programming languages we use conditional statements. The statements used in C or C++ for decision making is known as if statement. It means that if this condition is true, then only execute these statements enclosed within these braces. Now in C, in order to check this condition, whether the condition is true or not, another type of operators are used, and these are known as relational operators. And all these operators are shown in this table, and these are greater than, equal to, less than, greater than or equal to, less than or equal to, and not equal to. These are almost similar to the operators that we used in normal algebra. Note that in equal to, two equal signs are used, and as we know that in C, single equal sign has different meaning, which is assignment operator. In each of these cases, the result is either true or false, and the statement within these braces will be executed only if the result is true. Let's try one example using if statement. So here our program will ask the user to enter age of two persons. Then after comparing the ages, it will display some output. So I am creating a new file, say compare age.cpp. So here I am creating two variables of type integer, say int Ravi age and Rahul age. And then we are simply displaying a text, enter age of Ravi. Then using cin, we will take input from user and store the age of Ravi in the variable Ravi age. Similarly, again we will ask the user to enter age of Rahul, and storing this in Rahul age variable. Now here we will use if statement to compare both these ages. So I am writing if, and the condition will come here. So if Ravi age is greater than Rahul age, in this case I am displaying a message, say Ravi is older than Rahul. Let's save this and compile. So So let me enter the age of Ravi as 30, and as we can see that Ravi is older than Rahul. Let me run this again, and this time I am entering age of Ravi as 20 and age of Rahul as say 40, and you can see in this case this statement is not displayed. So this is our if statement, and inside this we are specifying the condition, and if the condition is true, then only this statement will execute, and if the statement is false, this statement will be skipped and program will complete the execution. Till now we have followed a very simple approach, which is seeing a problem and then immediately starting typing the code. This approach works only for short programs. For complex programs, which includes 100 plus lines of code, we cannot start writing the code after simply reading the problem. Before that, we have to analyze and create design for that problem. Now there are various techniques used for analyzing and designing, and flowchart is one of those. So using flowchart, we can pictorially show the sequence of activities or instructions. Each step is represented by boxes and some other shapes, and arrows between these shapes indicates the order in which step will execute. Then later, using this chart, we can easily write the actual code using any programming language. Through this chart, it also becomes very easy for programmers to trace and rectify any logical errors. Let's see the various shapes and what these represents. As we can see here, using these shapes we can create flowchart for any program. This is start stop symbol. Every program has a starting and ending point. So while creating flowcharts, we use this symbol for representing start and end of flow. Next is process symbol. Now this is the most commonly used symbol in flowcharts. We represent any operation such as assigning values, performing any calculation and similar activities using this process symbol. Then we have input output symbol, and as the name suggests, we use this when we are reading values from the user or when we are displaying some output to user. So to represent cin and cout statements, we have to use this symbol. This is decision control symbol, which is used for representing conditional statements. Then this is flow line, and it is simply used for connecting these other symbols, and its arrow represents the direction of execution. These two are connector and off-page connector. For instance, if there is not enough space on a page to complete the flowchart, we can continue the flowchart on next page, and to logically connect the two, we use these connectors. Just now we created this program demonstrating the if statement. Let's see how to create a flowchart for this program. First of all, every program has a starting and an ending point. Here main method is our starting point, and this closing brace is the ending point. So let's represent the start and stop in flowchart using these symbols. Next, we are taking input from user by asking the age of Ravi and Rahul. So in flowchart, we have to use input output symbol to represent this, as we can see here. This is the flow line, and the arrows indicating the direction or order of steps. Now we are done till this point. Next, we are using this conditional statement, and for conditional statements we have the diamond symbol in flowcharts. So we have written this condition inside this diamond symbol. Now the final step is to print this text if the condition is true. Let's see how this is done. As we are outputting something, so again we have to use this input output symbol. If the condition is true, then this flow line indicates the next step, that is printing Ravi's order. If the condition is not true, program will simply end and go to the stop. Also, we can see here that in case of true, after printing the text, the control flow is coming back to the normal sequence step and stops the flow. So this is the very simple example showing how to use flowcharts. We will see more complex flowcharts when we will discuss some complex programs. We have seen that using if statement, we can skip or execute a block of statements based on some condition. So if the condition is true, the block will execute, and if the condition is not true, nothing will happen and normal flow will continue. And this is what we discussed in this flowchart as well. In C, there is another structure as well, which is if-else structure. This allows us to specify another block of statement which will execute only when the condition is false. And this is how its block structure looks like. The first part remains the same, so if the condition is true, then only this block will execute. However, this new else part is added, which will execute only when the condition is false. Now in the program, if age of Ravi is greater than that of Rahul, we are displaying the message that Ravi is older than Rahul. Suppose if the condition is false, in that case as well, we want to display some other message, say Ravi is younger than Rahul. And this we can do in the else part. So let's modify our program. So here, after if I am writing the else part, and inside this I am simply writing that Ravi is younger than Rahul. Now let's try to run this. Now this time I am giving the age of Ravi as 30 and age of Rahul as 50. Now as you can see that Ravi is younger than Rahul. This else part is displayed because the condition is false. And this is the else part in flowchart. So we can see that if the condition is true, then this will be executed, and else this will be executed. So this is the if-else structure in C and C++. We know that in a statement we put some condition which either returns true or false. Till now we have checked only one condition, and if that single condition is true, we are performing further steps. But what if we want to test multiple conditions? Say apart from age, we want to check height as well. And if both age and height of Ravi is greater than that of Rahul's, then only print the message. For such conditions, we use logical operators. The most commonly used logical operators are AND, OR, and NOT. Using these operators, we can combine any number of conditions in a single if statement. First, let's see what are AND and OR. This table shows working of both these operators, and these are their symbols used in C language. Now, suppose these are the two conditions, expression 1 and expression 2, that we want to check in if statement. Now, if we use AND operator, the overall result of the if statement will be true only when both the conditions are true. And we can see this here as well. When both the expression 1 and expression 2 are true, then only the result is true. In any other combination, the result is false. If we use OR operator, the overall result of if statement will be true when even a single condition is true, and result will be false only when all the conditions are false. As you can see here, when both expression 1 and expression 2 are false, then only the result is false. Then there is one more operator, which is NOT. This simply reverses the meaning of a condition. So if the condition is false, then this operator makes that true, and if the condition is true, it makes it false. Let's see one example to see use of all these operators. So this is our problem statement. A company gives hike to their employees based on these conditions. Employees having salary from 5 to 10,000 will be given hike of 15%. Then 10% to those having salary more than 10,000 but less than 25,000. And then there is no hike for the employees having salary greater than 25,000. So let's see its flow chart. First of all, there is a start and stop of the flow. After this, we will ask the user to enter the current salary of an employee. So next is take salary as input. Then we will use conditional statements to check all these conditions. So first is, if salary is 5,000 or above but less than 10,000, then hike is 15% or 15 by 100, which is 0.15. Similarly, the hike is 0.10 when salary is 10,000 or above but less than 25,000. And finally, there is no hike, that is 0 when salary is 25,000 or above. Once we have validated the salary and the corresponding hike, we can calculate the revised salary and display that to the user. So the revised salary would be current salary plus hike percentage of current salary. Now let's see code for this flowchart. So here I am creating a new file, say raise salary.cpp. Now first I am creating two variables of type float, which is float salary and hike. Then first of all, we will ask the user to enter current salary of an employee. So enter salary of an employee. Then storing this value in the variable salary. So we have taken the salary from the user. Now next step is to check all these conditions. So we will be using 3 if statements, and then finally we will calculate the salary. So let's see this. So first I am writing if statement that if salary is greater than or equal to 5,000 and salary is less than 10,000, then we want hike to be 0.15. And similarly, the next condition is if salary is greater than or equal to 10,000 and salary is less than 25,000, in that case hike would be 10%, which is 0.10. And finally, if the salary is greater than or equal to 25,000, in that case there is no hike, so hike is equal to 0.0. So as we can see that we have used these operators and to combine one or more conditions, and finally we can calculate the salary by simply using this expression. So salary is equal to salary plus salary multiplied by hike, and once this is done we can simply display the output as revised salary is salary. Let's save this and compile the program. So it has compiled successfully. Now let's run this. Suppose I am giving the salary as 10,000. So in this case the revised salary is 11,000 because the percentage hike is 10%. Similarly, if I give the salary as say 30,000, in that case there is no hike, so the revised salary would remain the same. Let's try once more. Let me give the salary as 6,000. In that case the hike would be 15%, and then the revised salary is 6,900. So that's all from this lesson. In next lesson we will discuss about loops. Thank you.